So for taking in consideration all of the differences between the analog signal and digital form, you can look at next two slides that will represent the advantages and disadvantages of each form. Some people, for example musicians, and they prefer to still rely on analog signal. They can express that they lose the quality of the data when they encode the analog signal in digital form and decode it back. So they try to keep everything in analog form, especially in concerts. But this difference actually is very subjective. So you can actually use a very high bit rate to record or encode your analog signal in such a form so it will lose only 10 of 1%, the 10th part of 1% of the initial signal. And now we will get back to a form of the connection, and we will talk about how it is possible to send information within a one network with 2 and up to 10 devices, the data, and what equipment we require here. First of all, we need one equipment that make it possible to make a connection between all of the elements within a LAN network. For example, it can be a hub, a switch, and a router. A hub is a very old element that actually plays a role of the wire connection between different elements and used to multiplicate all of the data through all of the participant equipment. So the data that is transferred from A computer to the Z computer will also be received by all of the other computers within this local area network. The switch is actually much smarter than a hub and now is more popular to be used. It is possible now by using a switch to connect 10 computers and to send information from computer A to computer D that will be not transmitted to computer C, B, or any other computer that is not actually initiated to receive this information. And here we have addressing system. The addressing system consists of two elements, the IP address and the MAC address. Here, the MAC address is the manufacturer machine access control, so that every element, the network interface, has its own hardware address that is widely unique. And if you will be aware of what is about the situation that may arise when two providers or two manufacturers will provide the same MAC address, it is almost impossible, but because it uses this 48-bit identifier that has 281 trillion combinations. So it is a very big number to be repeated even accidentally. But it is more convenient to use IP addresses that are typically virtual addresses that can help you to send information to a destination. The IP addresses consist of 4 octets, 4 8-bit values that may identify the final destination of the data. And here we are talking about the IPv4, but also it is already possible to use IPv6 that can handle much bigger range of addresses that can be used within this addressing system. And we need to talk also about the subnet mask. The subnet mask is primarily used to identify the data route. So if you are using the local area network to transfer the data, or you are trying to address the data or the computer that is located in the wide area network. So the subnet mask can help you to distinguish the final address and can help to improve the performance of the data transfer if you are using the router system. So if we will take a look at the hardware and the representation of this lower layer, we will see the different elements that play a different role. The endpoints, like personal computer, mobile phones, that typically represent the final destination of data. The intermediate media, like routers, switch, hubs, bridge, gateways, and the hosting services that typically can be even a mobile phone and a personal computer, but usually it is the hosting servers that play a role of data storages and processing information from different sources and clients. And if we are talking about the hubs are a more primitive way to connect the elements, and they cannot provide you a better performance. And the switch is much better. It's a smart thing that can help you to address the data to be transferred to a particular destination. And also there is a wireless network like Wi-Fi. Wi-Fi is very interesting in way of the range that can be different of BGN and can be measured from 1 meter to up to 50 meters in the best condition in the direct connection within an element. And within a Wi-Fi we need to speak about the data throughput, because as much end devices connected to one Wi-Fi router, the throughput is divided proportionally between them. So if you connect, for example, if your Wi-Fi network provide you 50 megabits per second, and if you connect two elements or two devices within this router or to this router, this bandwidth is divided by 2. If you connect 3 elements, this bandwidth divided by 3, because they all use the same frequency of the wave. And if we are talking about the wave, why do we have a different categories of wave and the frequency? We need to get back to the information is that as higher frequency of wave we have, the higher penetration rate of the data, the penetration qualification of the wave we have, so it can transfer through walls and solid elements except metals, for example. And the lower frequency make it possible to refract the obstacle. So in different conditions the different kind of frequency are used. For example, a very high frequency is used in cellular network by 4G and even 5G for nowadays.